All right. So 1.2, slope of a tangent. So we will talk about average rate of change first, then instantaneous rate of change. So average rate of change is the change in the quantity of dependent variable y divided by corresponding change in the quantity of independent variable x over an interval. Okay, so uh, we show it as delta y over delta x, and this is equal to the slope of the secant between 2 points. So let's give a definition for secant first. Okay, so secant is a line uh, connecting 2 points on the curve. Let's say I have point P and point Q on a curve. If I draw a line between P and Q, so this line is called secant. Okay. So when you're calculating the average rate of change, so that is same as the slope of this secant. And you know how to calculate the slope of the secant from grade 9. So you do y2 minus y1 over x2 minus x1. So basically you take difference between the y coordinates and you divide it with the difference of the x coordinates. Okay. So but this time let's say point P has x coordinate of a. Then y coordinate would be f of a. So if you substitute x, in this case a, in f function, so you get f of a as a y coordinate. And let's say the difference between, the horizontal difference between point P and point Q is h. Okay, so I say this horizontal distance h. So then if this coordinate is a, then the other coordinate is going to be a plus h. Let me give you an example. Let's say a is 2, and the difference between these 2 points is 3. So 2 plus 3, this is going to be 5 if h is 3. All right. So if the x coordinate of point Q is a plus h, then the y coordinate would be f of a plus h. So basically you have 2 points, a, f of a plus h, f of a plus h. Then if I use this formula, delta y over delta x, I'm again taking the differences between so those two y values. So f of a plus h minus f of a is like y2 minus y1 over, now you take the difference between the x coordinates, a plus h minus a. And then you get, if you expand this, simplify, you get h for the denominator. Okay, so average rate of change is f of a plus h minus f of a over h. So this is called difference quotient, and it is fundamental to calculus. So that is average rate of change. It is very simple. You already kind of know, almost same as calculating the slope of a line. But this time you take 2 points on the curve. What is instantaneous rate of change? It is the rate at which dependent variable changes at a specific value of independent variable x. So this is not an interval. So when you're calculating the average rate of change, you have an interval from a to a plus h. But this time, you want to know the rate of change at one point only. Let's say at point P. Okay. So this is also equal to the slope of the tangent at x equals a. So what is a tangent? Let's give a definition for that. Tangent is a line that touches the curve only one point. Actually, we could extend this definition a little bit. If you have a curve, doing, let's say, this line, tangent line, yes, touches the curve in that local area at one point only, But actually later on it may pass through some of the other points. But in that local area, it touches the curve at one point only. Okay, so that is the definition of a tangent. So means, again, the instantaneous rate of change at point P is same as the slope of the tangent that passes through that specific point. Okay. So how can we calculate then the slope of the tangent so that I can calculate instantaneous rate of change? So we need the slope of the tangent. So now consider there's another point on the curve, like the previous question. Okay. So then this PQ would be the secant, right? If I have another point Q, this PQ is a secant for that curve. How about think that Q is a sliding point, okay? Q is a sliding point. Then we can now slide it along the curve towards P so that the slope of that secant will become progressively better estimate for the slope of the tangent at P. Okay, so for example here, well, this slope is different than that slope. But if I move this Q closer to point P, now let's say you have this secant. So the slope of that secant is closer estimation for this tangent. How about if I make it very, 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 very close that the slope of that little secant is very close to the slope of the tangent. Okay, if you make that Q very close to P, then it's going to be a very good estimation for the slope of the tangent. Then we said that the difference between, remember here, if this is the x coordinate, A, the difference between those two coordinates is h. Therefore, we said this as a plus h. So we want those 2 points to be very, very close. So we want that h to be almost 0. Okay? Therefore, how can we calculate the slope of the tangent here? We do this. F of a plus h minus f of a over h, like average rate of change. But this time we want h, which is the horizontal distance between those 2 points, to be almost 0. We want h approaches 0. Okay? And this formula will give you the slope of the tangent. Now let's look at some examples. Example 1. Suppose the temperature of an object obeys the formula T of t equals 2t squared plus 8t plus 9, where T equals the temperature in centigrade degree and T is the time in seconds. And we want this, so the domain is given, time is between 0 and 10 seconds. It says find average rate of change of temperature in the first 3 seconds. So this is same as, remember, the slope of the secant between those 2 points. Okay. So 1a, we are looking for average rate of change. Okay. So we want the difference between the y coordinates, so t of 3 minus t of 0 over, now difference between the x coordinates, 3 minus 0. So we can calculate now t of 3. So substitute 3 in this equation. So 2, 9, 8 times 3 plus 9, 18 plus 24 plus 9. What does this give you? 32, 42 plus 9, 51. So t of 0 gives you 9. Okay. So average rate of change, 51 minus 9 over 3. So 42 over 3, which is 40. Okay. And this is centigrade degree per second. So let's look at B. Well, let me sketch this so that you can also see what is the secant here. So if I put this function in vertex form, and if I complete the square, I get 2 times t plus 2 square plus 1. So this is a parabola. Vertex is at -2 and 1. Okay. And it opens up. And of course, you have the left side too. However, so since the domain is between 0 and 10, okay, so I can only take this piece, not actually, I should not put an arrow there, okay, 10. So t is in seconds, and then capital T is in centigrade degrees. Okay, so and y coordinate or y intercept is 9. For t of 3, why didn't we square it 2 times 9? I squared 3, which is 9. Okay, so what did we do so far? So we looked at, so this is 3, okay, 0 is here, of course, the origin. So we looked at this slope of the secant from 0 to 3. Those are the 2 points. Okay, and looks like that slope is 14, but that is also the average rate of change here. Okay, and again, slope of this secant is also 40. Let's look at B. It says instantaneous rate of change of temperature at 3. This time we are looking at instantaneous rate of change. Instantaneous rate of change. We said that the formula is limit as h approaches 0 of f of, in this case actually t, function t of 3 plus h minus t of 3 over h, right? So that's the formula we gave here. A plus h, but a now being 3, because we are looking at the slope of the tangent at 3, or instantaneous rate of change at 3 seconds. So a is 3, so you get f of 3 plus h minus f of 3 over h, but we have t function, not f, so I replace it with that. Okay, so we're going to look at this limit now. So I need, looks like, t of 3 plus h. So I'm going to sub 3 plus h for t in the given equation. Okay, so 2 times 3 plus h squared plus 8 times 3 plus h plus 9. Expand this. 9 plus 6h plus h squared plus 24 plus 8h plus 9. Expand the bracket. 18 plus, oops, 12h plus 2h squared plus 8h, so 24 plus 9, 33. What do we have? 2h squared plus 20h plus 51. Okay, I also need Q of 3, but I already calculated in the previous question, which is 51. Okay, now I can put those information here. Limit as h approaches 0, 2h squared plus 20h plus 51 minus 51 over h. Limit as h approaches 0, so 51 and 51 is gone. 2h squared plus 20h over h. So you have 0 over 0 here now, but looks like you can factor h and get rid of it. Okay, so h and h is gone. Limit as h approaches 0 to h plus 20. So substitute 0 for h now, you get 20 centigrade degree per second. So what did we do now? Let's check it on the graph, okay? So we calculated instantaneous rate of change. We said that also this is equal to the tangent that is drawn at t equals 3. Okay, so if I draw a tangent which is going to touch this graph at one point only, so that is a tangent at 3. So now looks like the slope of it is 20. You could factor 2, but I just needed to get rid of that h. That is the reason I didn't factor 2. Okay, so part C. Find the equation of the tangent at t equals 3. So we're going to find the equation of the tangent. Yep.
Can you go back one second? Yeah. First. Okay, thank you.
Okay, sure.
I'm good.
All right. So C, we are going to find the equation of the tangent, okay? And then we said the slope of the tangent is 20. Okay, slope is 20. And, you know, when you're writing the equation of a line, you get y equals mx plus b. In this case, actually, your x is little t and your y is capital T. Okay, and then we have 20 here. So it looks like we need to calculate the b of that tangent. So we need to substitute a point. So we can use, of course, the only point that we know on that line is this point of tangency, it is called. So x coordinate is 3 and y coordinate we calculated is 51. 51. My graph is not scaled, so don't worry about that. So if we substitute this, so we get 60 plus b. B is -9. The equation of the tangent is t equals 20t minus 9. So it means if you extend this tangent, the y-intercept is going to be -9. And the slope is going to be 20. Okay, so that's example 1. So let's look at example 2. So it says find the equation of the tangent to f of x equals square root of 2x minus 5 at x equals 7. So again, to write the equation of the tangent, you need to get the slope of the tangent first. So how do we get the slope of the tangent? We calculate instantaneous rate of change, right? So that is then limit as h approaches 0, f of a plus h, in this case a is 7, so f of 7 plus h minus f of 7 over h. Okay, so I'm going to do again this work on the side. So first let's calculate f of 7 plus h. Don't try to substitute the values in the limit and then calculate it there. It's going to get confusing. Do this work on the side. So you get 2 times 7 plus h. No, that's correct. Minus 5. So this gives you 14 plus 2h minus 5, 2h plus 9. So f of 7, you also need to calculate. Substitute 7, 14 minus 5, square root of 9, which is 3. Okay, so we then put those in this limit now. So f of 7 plus h, square root of 2h plus 9, minus 3 over h. Now check, substitute 0, what do you get? 3 minus 3, which is 0, over 0. So you have 0 over 0. So you need to remove that 0 over 0 situation. So in this case, we can rationalize the numerator, multiply it by the conjugate. So we can multiply it by 2h plus 9 plus 3 over square root of 2h plus 9 plus 3.
Miss Taz,
Yes.
so how did you get 14 minus 7 for F7 in the calculation?
So I substituted 7 here.
Okay,
2
thank
times
you.
7, you're welcome. X is 7, right? So you sub in the f function. Okay. So now we created a difference of squares here. So this gives us 2h plus 9 minus 3 squared is 9. H times square root of 2h plus 9 plus 3. If you simplify, so you get 2h over h times square root of 2h plus 9 plus 3. Okay, h and h is gone. So you get 2 over square root of 2h plus 9 plus 3. So when you simplify these two, you removed 0 over 0 situation now. Okay, so you can substitute 0 for h now to calculate the limit. So you get square root of 9, which is 3 plus 3, so 2 over 6, 1 over 3. Now we can write the equation of the line. So y equals mx plus b, y equals 1 over 3x plus b. So we need a point. Again, the only point that we have is x. We know the x coordinate of it's 7. So we found f of 7, which is the y coordinate at that point. That is 3. Okay, so now 3 equals 1 over 3 times 7, which is 7 over 3, plus b. 3 minus 7 over 3 equals b. So 9, 2 over 3. So b is 2 over 3. So y equals 1 over 3x plus 2 over 3. This is the equation of the tangent. You can see. So this is what it means. If I sketch the graph and show you here. Okay, so we had Okay, so the question, our f of x function is square root of 2x minus 5. Actually, if you factor that k value, you get x minus 2.5 or 5 over 2. Okay, means that there's a horizontal shift 2.5 to the right. So this graph is something like this. Okay? So here is 5 over 2. Okay, so now we found the equation of the tangent where x is 7. So looks like when x is 7, y is 3. And then we looked at now the tangent at 7. And the equation of that line is y equals 1 over 3x plus 2 over 3. Maybe I'll show the whole page. If you want to take a picture. Okay. Let's look at other examples. Example 3. So we are given f of x equals 3 minus x over 2x plus 1. So we want to write the equation of the tangent at x equals 2. Again, to write the equation of the tangent, we need the slope. And slope, or instantaneous rate of change, is limit as x approaches h approaches 0, and we need to do f of 2 plus h minus f of 2 over h. Again, on the side, let's calculate f of 2 plus h. So 3 minus, so replace x by 2 plus h. Make sure you use brackets as you do that. Otherwise, you will get wrong answer. So 2 times 2 plus h plus 1. So 3 minus 2 is 1 minus h. And then 4 plus 2h and 1 plus 1. So let's look at f of 2. Substitute 2 now. 3 minus 2 over 2 times 2 plus 1, 1 over 5. Okay, so limit is h approaches 0. So we have 1 minus h over 2h plus 5 minus 1 over 5 divided by h. So there is too many fractions here. Sometimes it may be harder to deal with it. So my recommendation is take this h and put it in front as 1 over h. Okay, so limit is h approaches 0, 1 over h. Now we have to simplify this part. Okay, so we can have a common denominator here. Multiply first fraction by 5, second one by 2h plus 5. So we get 5 times 1 minus h minus 1 times 2h plus 5. Do not forget the brackets. and denominator is 5 times 2h plus 5. So limit is h approaches 0, 1 over h. Expand those brackets. So you get 5 minus 5h minus 2h minus 5 over 5 times 2h plus 5. Okay, so 5 and 5 is gone. You end up with negative 7h over 5 times 2h plus 5. Now you can simplify h, and as you do that, you remove 0 over 0 situation. You get negative 7 over 5 2h plus 5. Okay, now you can substitute 0 for h, and that gives you 25 here. Negative 7 over 25 looks like the slope of the tangent. So y equals negative 7 over 25x plus b. Again, we need to solve for b here. We need the point. We use point of tangency. X coordinate is 2. And f of 2 is 1 over 5. We're going to use this point. Okay, so 5 equals, so 2 times negative 7 over 25, negative 14 over 25 plus b. 5 plus 14 over 25 equals b. Have a common denominator. Oh, that's not 5, this is 1 over 5. Okay, so then you get 19 over 25 equals b. So y equals negative 7 over 25 x plus 19 over 25 is the equation of the tangent. So if you were to sketch this graph, so there's a vertical asymptote at negative 1 over 2. And there's a horizontal asymptote at, if you look at the coefficients of x and x, so that's negative 1, that is 2, negative 1 over 2. So it looks like the horizontal asymptote is also y equals negative 1 over 2. And this graph is something like this. And there's another piece there. So far, what did we do? Oops, this is x. So we looked at the tangent at x equals 2. Okay, I think 2 is somewhere here. Again, this is just for demonstration. Okay. That is a tangent at x equals 2. So 2 and 1 over 5. This graph is not scaled. The equation of this tangent is negative 7 over 25x plus 19 over 25. Did you want to see the previous page? Yeah? You're fine. Okay. All right. So moving on, the last example. So should I show the whole thing? Okay, so let's do that. So let's see. Okay. The last example. Example 4. We are given y equals x cubed minus 9x. It says find the points on the graph of y equals x cubed minus 9x at which the tangent is horizontal. Okay, so you have a graph, okay, and then you are looking for tangents are horizontal. So now you need to remember the slope of horizontal lines, right? Slope of horizontal lines is 0, right? So we want to know where the slope of the tangents are 0 for this function. So what can we do that, right? How can we do that? We don't know this time, as you see, the x coordinate of the point is not given. So you have to find out what that x value, okay? So we don't know that point, but let's say the x coordinate of that point is a, okay? Then the y coordinate is going to be f of a plus h. So sorry, that is f of a. So we don't know what a is. That is what we are trying to find out. Okay, so if you write the slope, so we say limit as h approaches 0, f of a plus h minus f of a over h. So now we need to substitute a plus h in the function. A plus h cubed minus 9 times a plus h. So a plus h cubed, so you can write it as a plus h times a plus h square minus 9a minus 9h here. Now expand this, a plus h times a square plus 2ah plus h square minus 9a minus 9h. Okay, now expand it further. A times a square gives you a cube. A times 2ah, 2ah square. A times h square, no, that is 2a square h. A times h square, ah square, h times a square h, h times 2ah, 2ah square plus h cube. I still have minus 9a minus 9h here. So collect a cube, 2a square h, 1a square h gives you 3a square h. A h square 2a h square plus 3a h square plus h cubed minus 9a minus 9h. Okay. We also need f of a. So sub a, so you get a cubed minus 9a. Okay, so to be able to fit this, maybe I'm going to do it here. F of a plus h, so I have a cubed plus 3a square h plus 3a h squared plus h cubed minus 9a minus 9h minus a cubed minus 9a, which is f of a, over h. So a cubed minus a cubed is gone. And this gives you minus 9a gives you plus 9a. So minus 9a plus 9a are gone. So I have 3a squared h plus 3a h squared plus h cubed. We said this is gone. We still have minus 9h. And a cubed is gone. So you can expand this and see, right? All right, over h. As you see, we still have 0 over 0 situation. We can factor h from the numerator. 3a squared plus 3ah plus h squared minus 9 over h. So h and h is gone. So you removed 0 over 0 situation. Okay. Now substitute 0 for h. So you end up with 3a squared minus 9. So now actually we got the equation for slope, okay? So A, we don't know what that A is, right? But now we have a general equation or slope formula for all the tangents to x cubed minus 9x to the given function f of x. So this is very practical. Let's say, after this point, after you get this formula for the slope of all the tangents, now you don't have to calculate the slope of the tangent each time by doing, this formula here, right? For example, you want to know slope of the tangent at x equals 2, then you can directly use this formula. Now, this is because this is a slope formula for any arbitrary x value. So you can sub in 2 squared is 4, 4 times 3 is 12, 12 minus 9 is 3. So now you know that slope of the tangent at x equals 2 is going to be 3. Or you want to know the slope of the tangent x equals 0. So sub in, so you get slope being negative 9. Okay? Any number, let's say x equals 1, you want to know the slope of the tangent. Sub in, you get negative 6. Okay, so you don't have to do now, let's say for x equals 2, you have to do limit to calculate the slope. You have to do limit as h approaches 0, f of 2 plus h minus f of 2 over h, right? Or for x is 0, you have to do the same thing. For x equals 1, you have to do the same thing. But when you have a general formula, you don't have to do them anymore. So you can just find the slope of the tangent by subbing an x value in this formula. Okay? Actually, this formula is the derivative. We're going to learn it in chapter 2. But this function that we get for the slopes of the tangents is the derivative of the original function. Okay? So let's come back to our question. Our question was asking where the tangent is horizontal. And we said that horizontal lines have slope of 0. So we want this slope being 0. So 0 equals 3a squared minus 9. So we get 9 equals 3a squared. 3 equals a squared. A equals, now you take the square root of both sides, plus and minus root 3. Okay, so if we sketch this, So original function is y equals x cubed minus 9x. So if you factor x, you get x squared minus 9, x minus 3, x plus 3. You can factor this. So now you see the x-intercepts of this original function. And it's a cubic function with a positive leading coefficient. It goes from quadrant 3 to quadrant 1. Okay, so we got that at x equals negative root 3, and positive root 3, the tangents are horizontal. Okay. So whenever you have local maximum or local minimum, the tangents will have a slope of 0. You can also find the y-coordinate of those points by subbing them in the function. So f of positive root 3 cubed minus 9 times root 3. 3 root 3 minus 9 root 3 gives you negative 6 root 3. Also, let's find f of negative root 3. So negative root 3 cubed minus 9 times negative root 3. That gives you positive, negative, so 6, positive 6 root 3. Okay, so y-coordinate of those points, this is 6 root 3, and that one is negative 6 root 3.